So let's try to tie this to an application. What kinds of functions do I want to study? And what kinds of areas those functions give me is something that's going to change depending on, what your major is and what your job is, what you're using this tool for. For right now, let's take an example where we are graphing two different cars. So I have curves A and B, and A is the graph of the velocity function for, let's say, car A. B is the graph for the velocity of some car, call it car B. And the way this is drawn, the curve A always is above the curve B. So I can ask now, from the calculus point of view, what amount of area is between those two curves? But perhaps more to the point is, why would I care about such a thing? What new information does that give me? So can we interpret this amount of area? Well, sure we can. So judging by the scale that this graph is drawn at, I'm starting at t coordinate 0, and t seems to be measured in seconds. I'm finishing at t coordinate 16. And when I integrate velocity, I know that I get distance or position. So the amount of area beneath the curve A is going to be the distance traveled by that first car. The amount of area beneath the curve B is going to be the distance traveled by the second car. And I can subtract distances. That's an easy thing to do. They're just numbers. What is that representing here? The area between the two different curves is telling me the distance, not the distance traveled, but the distance between the two different cars. So I can see here at 0, well, they're starting in the very same place, maybe. Or maybe not. Does that matter for this velocity graph? I don't think so. But whatever that distance between the two cars was, I can see that car A is driving faster than car B, so the distance between them will be growing, whatever it started at. Further, can we actually calculate that distance? Well, this graph is labeled very nicely. So if we really wanted to, we can say that each of these boxes is representing 1 second on in the horizontal direction, and each box is representing 5 miles per hour in the vertical direction. Excuse me. So if we really wanted to, we could associate amounts of distance to each one of these. So approximating in that way, I would say that each box is going to be worth, let's see now, delta t equals 4. Aha, so this is actually a midpoint approximation. So we're going to use a Riemann sum, n equals 4, calculate that all out, and we get an amount of area. So how much further has the car A pulled ahead than the car B? About 372 feet. Now, I am skipping some of the algebraic details on this because most of our applications, we will be given functions. We'll be given formulas we can calculate, find antiderivatives. But if we really had to, we could set up simple Riemann sums and get an approximation for whatever we're searching for. In this case, the distance between the two cars.